Hello, everyone. My name is Dewan Ahmed. I'm a senior developer advocate at Aiven, and today I have with me Peter.
Cool. Thanks, Dewan. I'm Peter. I'm a senior DevOps engineer at WebRiot. And so Dewan, let's back over to you. Why don't you get us started?
Awesome. So today, Peter and I are here to help one of our friends. That friend is called Rapu, the crab. So Peter, you know what? Rapu just started as a junior engineer at Crab Inc. And Rapu is facing some challenges. I heard Rapu was trying to deploy cloud resources all over in the dev environment, in the production environment, in all different cloud regions where he shouldn't. So how can we help Rapu, Peter?
Cool. Yeah, and this is not a problem that's specific to Rapu. This is something that a lot of junior engineers come across when you have tools like Terraform that allow you to replicate things very easily. You end up having a lot of options to choose from that have a lot of power in their configurability, right? And so with Rapu, he's looking at things that the team is doing over in Canada and what the team is doing over in US East, and he's seeing that he's seeing their configurations, and right, and he's grabbing and picking and choosing and creating stuff, and it's just going all over the place. And so what we're going to do is we're going to help Rapu by using Open Policy Agent. We're going to build some guardrails for Rapu so that when he is creating his own Terraform policies, right, he can understand and know where those policies are, or those policies will know where the resources are going, what kind of configurations they're using, and they're gonna keep Rapu within the boundaries of where he wants to be.
Yeah, exactly. And I think to visualize the setup, we can get started with presenting a high-level overview. So let me share my screen. Awesome. Let me zoom in a bit so that it's clear. All right, so here's a high-level overview of the system. So at the top level, you can see that we have Terraform. Again, it's an infrastructure as code tool. You can use a different tool, but the overall concept would be the same. So you're running Terraform or some other tool to create some cloud resources. So in this case, we're using a console or a platform called Aiven. So Aiven is the trusted open source data platform for everyone. That means you can run Apache Kafka, PostgreSQL, and other popular open source projects as managed services on this platform. So coming back to the challenge Rapu is facing, so Rapu is deploying these cloud resources. In this example, as Aiven for Redis, Open Policy Agent is sitting in the middle with some policies. The policy would have an allow decision and a deny decision. Peter, would you be able to go over the detailed version of this diagram?
Cool. Thanks for that. Yeah. And so now we're looking a couple more pieces here, right? We have this local dev machine, and this is where you can think of this developer or engineer is creating the files that they're going to need, right? And so for our particular use case here, we're talking about Terraform. So we're going to create a Terraform HCL file that's going to define the resources that we want. And then we're also going to define the Rego file, or the policy that Open Policy Agent is going to enforce, right? We're going to take those files, we're going to check them into our version control, and then they're going to go through some processing, right? And so if you have a standard CI/CD tool, maybe like GitHub Actions, which is a very friendly one to get started with, right? You can now have actions that will process that plan, or that Terraform plan, right? And so in this case, for OPA, we're going to need that plan to be in JSON, not HCL. So we're going to tell Terraform to output the HCL as binary, and then we're just going to run a little convert command to get that binary into the JSON format that OPA likes. And so now we're going to take that input JSON file along with that Rego policy that we wrote, and we're going to try to create those resources and see if OPA will either have Aiven create those resources or send us an error message. And so that's kind of the workflow that we're going through here, left to right.
Fantastic. And because we're going to be doing a lot of things, for ease of understanding, we have divided this into 3 sections. In the first section, we'll set up the Terraform files. And in the subsequent sections, would be adding more and more to this demo. So let's start with the first section. And forgot to mention, we do have a GitHub repository with all the Terraform files, the Rego files. So this is the repository at the top. It will be linked in the video description as well. So feel free to start that, fork that, but all the instructions would be in this repository. So, all right, so let's go to the first section, which is set up Terraform files. Now, if you'd like to follow along, the first thing you need to do is sign up for an Aiven account. There's a free trial, there's a free tier, as well as a trial version as well. So from that, what you want to do is click on the top right from your profile and click on tokens. Because if you're signing in through the UI, you're already authenticated. But if you're invoking commands through Terraform, then Terraform needs to know who you are. And that's why you need to use tokens. So you can generate tokens. So I've already done that. Here, we're going to create some Terraform files. And let's start with the first one, which is provider.tf. So what provider.tf tells us is which provider to use. So in this case, we're using Aiven Terraform provider. This is available on the public Terraform registry. So this is the provider, and this is the provider docs. So let me copy the first file. So on my VS Code, I can create a new file, provider.tf, and paste it here. So if you see that version I have is 4.1.0, when you're watching this video, you can use the most up-to-date version. All right, the second file I have is the variables file. So just like good programming practices, you have some values which you use variable rather than hard coding values. So this would be my variables.tf. So two of the variables we were using is one is Aiven API token, and the second one is project name. All right, so let's go to the next one, which is the main essence of this Terraform folder, which is services.tf. So in this file, we're actually defining the Aiven underscore Redis resource, which is this one right here. And here there are four parameters which are mandatory. One is the project name. The second one is the plan name. So the plan name is Aiven's way of telling you like what's the memory, what's the CPU, and you can choose a plan based on your need. You can use a higher plan or a lower plan depending on your need. The service name could be anything. So I'm calling it Redis demo. And cloud name. So we allow you to deploy to any of the 5 cloud providers, including 3 of the major cloud providers. So here I'm deploying to Google North America Northeast 1, which is the Montreal region. All right, so I think that's pretty much it. I also have exported the Terraform variables, so the API token and the project name as Terraform environment variables. The details for that is in the GitHub repository. So with that, Peter, I think I'm ready to start the Terraform commands.
All right, let's do it. Let's create some Redis instances, and then while you're running those commands, why don't you also tell us, are there any differences between this Aiven Redis and maybe a Redis that I'm used to running on my local machine from just like directly from the open source repo?
Great question. So while the Terraform command will actually take some time, so let me start those, and then I'm gonna take that question. So the first thing I'm doing is Terraform init. So you have a blank folder and some Terraform files. What Terraform init does is initializes the project and downloads the provider backend. So once that is done, the next step is Terraform plan. So plan doesn't actually create the resources. So if I show you my console, so let me show you the console. It's empty. There's nothing there because plan only shows a preview of what will be created. So nothing has been created yet. Terraform only telling me that this is the resource that will be created, and it seems fine. And now I'll do Terraform apply. So Terraform apply will actually create the resources, which runs Terraform plan at the background as well. So once I do that, again, it looks okay. So it's going to create an Aiven for Redis, and I can see like the cloud name and those 4 resources are there, but the other resources, which I didn't specify, has the default values. All right, so once I do yes, then the resource will actually be created here. And okay, this is a good time to answer that question. So at Aiven, we focus on giving you the scalable, reliable, secure enterprise version of the software, but they're as close to the pure versions of their open source as possible. So that means you as a developer, if you just spin a Redis container on your machine, you can use it, but then it doesn't have the platform advantage. That means the reliability, the security, scalability, those things. If you as an engineering have to do, you have to either do it yourself or you have to have the consequences if the services fail without the scalability in place. So that's, in short, the difference between, let's say, having an open source Redis just running on your local machine or just managed internally versus using a platform.
Awesome. Thanks for the info. And then, so I see you're connected to Google Cloud here. So what's the difference there between like a Google Cloud Redis and an Aiven Redis? Because to me, right, like am I going to be able to connect to either of those exactly the same, or what's going to be the difference?
Yeah, that's the beauty of the abstraction. So what Aiven platform gives you is that abstraction layer. That means you can point Google Cloud Platform, AWS, Azure, DigitalOcean. It doesn't matter, because at the end of the day, you're getting this service URI. You can use this URI and have your application connect to these different services. So if you have data residency or compliance needs, you can ensure that your data resides in one specific region. If you want to target specific clouds, you can do that without your developers needing to know about all the details about, let's say, AWS or GCP. So you don't need to be an AWS or GCP expert to deploy services on those clouds.
Awesome. Thanks for the info.
While the service is being created, we're going to see the next piece, what we'll do. So this was the challenge, right, Peter? Like, this was what Rapu was doing before. Like Rapu, so this was what we did, the Terraform init, and we executed the Terraform commands without OPA in place. Rapu was doing the same, so there was no guardrail here. So next, we'll see how, if we have a guardrail in place, Rapu can have allow decision for deployment, but also deny decision as well.
Yep. So thanks for that. And so as we saw in that repository, right now, we're going to look at that output, right? So what Dewan did previously was just to apply, right? Just to go right in and create this. And so now what we want to do is we want to add a step beforehand. And that step beforehand is going to be a policy check. Right. And so we are going to show this policy check manually, just running this locally on Dewan's machine. But right, if you're set up in more of a production environment, this is going to run your CI/CD pipeline or in some sort of automated process where these checks get run every time you check in your Terraform plan, so that you know on every create, these policies get checked. And so with this policy now, let's head on over to, I think we have I think you have it in VS Code. We might have to copy it in.
Yeah, it will probably take a few more seconds. So let's see how the service is doing here. So here we can see like the solid green indicates that the service is up and running. Typically, like the terminal takes a few extra seconds to update. Mm-hmm. So let's give the terminal a few extra seconds to catch up.
Good timing.
Perfect. So the apply is complete. So here, what we'd like to do is to Terraform destroy. And this is one of the advantages of using an infrastructure as code like Terraform. So for example, if you have multiple resources, like dozens of resources created, let's say it's in your test environment or dev environment, and you want to clean up everything, one Terraform destroy will clean up all these resources, not just one resources, and you won't have a dangling resource somewhere giving you a heartache of like thousands of dollars of cloud bills at the end of the month just because you forgot to delete that one resource. So that's one of the beauty of using automation over manually clicking to create and delete services. All right, so now the service is gone. We have a clean slate. That means now we can use OPA to enforce some fine-grained access control. So what I'm going to do is I'll go to the repository, go right here, First, we need to create the tfplan.binary. Awesome. So tfplan.binary, and you can see on the left-hand side of your screen, now we have this file which didn't exist before. But we need to convert this binary into JSON. So this is the command to do that. And now we have a tfplan.json. And in the repository, we have a sample file of this tfplan.json. Don't worry about the API token. By the time you're watching this video, the token is already invalid. All right. So now I think we can go back to the next section, right, Peter? So we can now.
Yep. That sounds good. And so now that we have that JSON file, right, and we saw that JSON file had a bunch of information in it, that had information, configuration information, it had status information, it had information about the cloud it's connecting to, but all of that's in structured format. It's in that JSON structure. So now with OPA, we're going to be able to easily navigate through this JSON structure, right? And that's how our policy is going to work. Our policy is going to take elements of that JSON and check that those elements are what we expect them to be, right? And so here so first thing we're going to do is we're going to create an empty file with a .rego type, and that .rego is our policy file that is going to be a purpose-built policy language specifically for Open Policy Agent. And so in here we have quite a few lines. Can you scroll a little to the top, and I'll just go top down. We have a package name at the top, and this package name is going to be a logical grouping of policies, right? And so in this particular case, we have Terraform.analysis. So you can just think of this as a package of analysis tools that we might want to use, but we might have Terraform.gcp, we might have Terraform.prod, right? Like, so we might separate these policies logically in a different way depending on how your team or how your product or project is structured. But remember, this is a logical grouping, completely up to the engineer or developer. Next up, we have these two imports. Hold on. Let's show the imports real quick. So there's two imports. We have one input as tfplan. This is just us creating an alias. This is going to make our policy a little easier to read by knowing that we are digging through the input, which for this policy is going to be a Terraform plan that we've converted to JSON. And then we have an import future keywords. This is going to give us some of the more fun words to use here, like if and some. But we will go through that. We will go through how those words work or how those keywords work as we go through the policy here. And so these first three lines here, 6, 8, and 10, we are hard. Or I guess for the first two, 6 and 8, we are hard coding a couple of values here, right? We have this first one, which is our desired development environment, Google North America Northeast 1. And then we have our desired prod environment, which is AWS US East, right? So this is where Rapu is going to get tripped up, right? Because for Rapu, I believe lives in Montreal, right? And now he's accidentally sometimes deploying to prod, and so we need to make those logical boundaries for him so that when he is creating these things, he does not get caught off guard. And so now underneath that, we have line 10, which is our resource types. These are the types that we are creating policies for, right? So we're scoping the limits of this policy to only react to these resources, so that so anything else that is created will just be able to be created without going through this process. And then underneath that, we have a couple of defaults, and both of these defaults are set to false, right? Allow dev deployment, allow prod deployment. This is a standard practice for any sort of code that is declarative. You want a default state, right? Because we are declaring what we want this policy to do. We need to declare what should happen when the policy doesn't ring true, right? So if our allow policies don't go through, right, then we would be left in an undefined state. So therefore, we're going to define these defaults to say, this is what we expect to happen if nothing else happens later. So we're going to set both deployments to false. And then we have our 2 checks here, one for our dev deployment and one for our prod deployment. And you're going to see here, everything is the same except for the last line. And so this first line is going to be some resource, right? And that some keyword is going to say, like, it's going to create a variable for the word resource in TF plan, which is that Terraform plan we have. And then we're going to dig into that JSON object and look in the plan values, .root module, .resources. So this is going to be all of the values that Terraform plans to create, right? And then so now that we have that some resource, right, we're going to dig through each of those resources in there, and we're going to look for resource.type. And resource.type in resource types, right? And so this is saying those types that we defined earlier are the type that we are looking at, right? And so now for these policies to continue, each of these lines have to be true. So now the first line is just us checking each object, and then the second one is verifying the type. And now we're actually going to do some string comparison here, right? And so now we're just going to look at that resource.values.cloud name. This is the cloud that Rapu is deploying to, is going to be starting with that variable we created, dev env cloud prefix, right? And so if it is a development deployment, right, it should have that Google North America Northeast. And then if it is a prod deployment, we're going to have that AWS US East, right? And so this is how we're going to know one of these policies should always ring true. Or else Rapu is trying to deploy somewhere completely different, and that is out of scope, right? And so then we'll go back to that default deployment equals false. And so now we have our policy defined.
Yeah. So now that we have the policy defined, now let's exec this policy. Do we have it here in the policy folder? Let's see. Policy. So this is the Terraform.Rego. So I think we mentioned that we're going to have this policy in a policy folder. So let me just quickly have a folder just so that we can match the repository. So we have a folder called policy, and I think the Terraform.Rego will go into this policy.
Yep, and this policy folder is nothing special, just a logical bucket that we are keeping these policies in just for just file management.
Yeah. All right, so now the first one is exec the command. So I'm going to copy, and then we're going to go through what it means. Let me see. I think don't need a /. All right, so let's go over what happened here. So we did OPA exec, decision, Terraform analysis, allow prod deployment. So this is what we're checking this decision against what we have in the policy. So the policy is the Terraform.Rego policy, and the input we're getting is the tfplan.json. So let's first check the input, the tfplan.json. So the tfplan.json is right here. And if I try to see cloud underscore name, so let's see where we have the cloud underscore name. So this is the cloud underscore name. So, and we already know that this is Google North America Northeast 1, which is the development region. So this is not the prod region. So now we're matching that against the policy, which is Terraform.Rego, this particular policy. So we're saying that we allow prod deployment if only the cloud underscore name matches this prefix. That means the cloud underscore name should start with AWS US East. It could be AWS US East 1, 2, any number after that or a string after that. But in this case, because we have Google North America Northeast 1 region, the decision from OPA was false. So Peter, what would you like to test now? Could we change it to true?
Yeah, and so in this particular case, right, we know that Rapu has made the right decision here. He has set his deployment to Google North America Northeast 1. right? And so yeah, as you can swap that out there, right? And so for the decision, right, we have OPA exec decision, right? And this means that we are asking OPA to evaluate one policy rule inside of the overall policy package, right? And so this is very typical for like a CI/CD process or something where you don't need to run the entire policy package. You just want to know the output of one thing. And so like if you are running a prod deployment, right, you can just check the one prod rule. And so now, right, we can see that by switching the decision, we can see that this would work for our prod. So why don't we try to change our service to point?
So a quick note is this now worked for the dev deployment, because I switched the decision. Now we're checking for allow dev deployment if it's true or not, because the previous prod deployment was false because we're using Google North America Northeast 1. But that is the region, if you see dev environment cloud prefix, that means Rapu can deploy here if this is a dev deployment. That's why when we checked this allow dev deployment is true or not, this is true, because yes, it is a dev environment where Rapu can deploy.
Sounds good. So now let's try to update our Redis instance that we're creating and see if we can change this up a little bit.
Cool. Would you like to go to the next section, or would you like to check anything else?
Let's hop on over to the data section, and then we can go from there. We can make our updates.
And as you can see, the modules in this repository are nicely divided into different sections. So if you are trying to see like which part we are in the video, we're going to have like different section title, but also these different modules will help you identify where we are in the demo.
Cool. So let's create this data.json object.
Perfect. And I think the data.json would be in the policy folder. Right. So right here, new file, data.json. And I'm going to paste the content here. Let me bring it up right here. All right. So what is this data.json doing, Peter?
So this data.json, it's a very small JSON block here. As we can see, there's only about 10 lines. And so what we're defining here are a couple variables that we expect to have, right? And so if you remember earlier, I mentioned we hard-coded a couple of variables for these cloud names, but right, that's not exactly best practice to hard-code your variables directly into your policies, because then you have to go and update your policy anytime you need to change these things. But if you want to move things around, if you have a different development team, right, you want these policies to be modular and adaptable to the use cases that they're working with. And so we have this data file here, right? This data.json. So now when the policy is run, we can pull variables out of here, right? And so now we can say like, oh yeah, check that dev.cloud or check that we're using dev.cloud or we're using prod.cloud, right? So we can see in this updated Rego file, we've removed those variables. And now in that string check, we are accessing the same information, but from that data block.
Perfect. So I think what I have to do is, first of all, I'm going to remove this hard-coded block, right?
Yep.
All right. So let me do that. It's always fun to remove hard-coded stuff. All right. Mm-hmm. So now I'm going to come here because the file does not know about dev environment cloud prefix anymore. I'm going to switch it with data.dev.cloud. And I think similarly, I can do it for data.prod.cloud, which is right here. And one more time for our viewers, I'm going to show the data file. So data file dot dev, like nested, and it's finding the value of the cloud right here. And similar way, prod cloud value from here.
Cool. All right. So let's recompile this check. Let's run our Terraform plan again. Let's create that binary, convert it to JSON, and then run that OPA exec to see that we are still seeing the same outputs on this file.
Cool. Let's do that. All right. So one quick question, Peter, is because we didn't change the tf plan.json, the JSON file still had the same value. Would it make sense if we just ran the OPA exec command one more time? Because the tf plan.json didn't change. We're only changing it in the policy file and then adding the data.json.
You are correct. We did not modify the plan file, so the plan would come out exactly the same. So we can just go straight to the exec.
Perfect. Let me do that. The result is true as expected, because after we modified, now we're checking the dev deployment. It's true because it's Google North America Northeast one. So it seems that after adding the best practices, like adding the data.json file to remove the hard-coded values, the policy and the commands are still working, which is a good thing. All right, but we don't want to do all the work, Peter.
That is very true. Like, there's a lot of policies to write, and so we should get the viewers involved as well.
Perfect. So here's some challenges for you, and you can add some rules on your own. Now, the two policies you already have in place, like allow dev deployment and allow prod deployment. We challenge you to add two more policies. The first challenge is the project name must start with the team name. So you know that the project underscore name is already a variable, and then here within the data.json file, you have a team name, right? So you should add a policy that checks that the project name should contain the team name or start with that. There is different keywords, right, Peter? Like starts with and contains. So there's different keywords.
Yeah, and we are using simple string checks here because this is a bit of a demo, right? Like, as you get more comfortable with this, you can do more advanced features, right? You can use built-ins from OPA, like you can do HTTP calls, you can, extract data from a JWT token, right? Like, there are a lot of other built-in features in the policy language for you to work with other data types. But for just this demo, right, and having a simple JSON object, we're going to do some simple string checks. So, but yeah, I encourage people to play around with the other built-in features, maybe augment that data block, put something else in there, and try to make it a little bit more complex and get a little more experience with the policy language.
Yeah, and I think they can refer to the Open Policy Agent docs as well, right? To find out like what are the keywords. Like, for example, if I do starts with, like, is this the right place to find out about these keywords?
I think that pulled up one of the tutorials. And so if you search for starts with again.
Starts with. Is it the built-in function?
Yeah, built-in functions. And this is going to give the list of all of the built-in functions, right? And so, like I said, we're doing a string comparison, and you can see that we have a handful of built-ins to work with strings. But on the left-hand side here, you can see you can work with regex objects, blah, bitwise conversion, units, types, token signings, cryptography. There are a ton of different built-in function types, and then specific actions you can do within those. So, like I said, I encourage you to play around with these, try a few out in these example policies, and get a little bit of experience.
Perfect. And we already gave plenty of hints. So the second one is the service name. So the service name is this one. Let me go to the service.tf, and this is the service name. So the second challenge is write a policy that checks that the service name must include the app name, and the app name you're getting from the data.json. All right, so I think this is a good time to segue into unit testing. There is something that can be optional, but unit testing or testing in general is not one of them. Testing is never optional. So our Terraform OPA tutorial also will have unit testing. So Peter, let me open up that section, and then you can talk about that one.
Yes, all good development deserves good unit tests, right? This is how we know we're making clean code. This is how we know that we're getting the outputs that we want. And as we update and change things, we know that our code is still doing what we expect it to do. And so with that in mind, right, Rego, being the purpose-built policy language, has a testing framework built into it, right? And so what we are looking at here is a Rego policy just for the unit test for what we just wrote, right? And so we can see the package name is a little bit different. Before it was Terraform.analysis, and now we created a separate test package, so Terraform.test_analysis. And then the second line, this import, remember last time we were importing to create aliases or to add functionality to the policy. In this case, we are actually importing the policy we created earlier so that we can check those rules. And so with this first rule here, right, we see test_allow dev deployment. And remember, allow dev deployment was the rule we initially created. So having that prefix of test_, lets Open know that these are going to be unit tests. And when we start the testing process, it will automatically kick these off and know what to do. And so with each of these,
so let me add the test_terraform.rego, and feel free to explain, but let me do that while you're explaining, which would be test_terraform.rego. Perfect.
Great. Yeah. And so like here we see we have two tests in here. We have a positive and a negative, right? And so in one of these, we are checking that we have a data. We have this mock data that is going to be going to allow a dev deployment. And then I think the second one is to not allow a dev deployment, right? And so we're just kind of showing a positive and a negative outcome for this particular rule, right? And so we're just kind of getting good test coverage. And so as things get more complicated, you might want to throw curveballs into these unit tests and see what happens when, right, you do a cloud name that's not included in the list at all, or maybe you want to change the plan that it's running on, or the project names, right? You might want to modify these and see, right, you might want to run unit tests around more functionalities than just the cloud names. But, right, this is getting to just the core functionality of what we're working with today, which is just putting the guardrails around the cloud that Rapu can deploy to.
Absolutely. So as a good citizen, I'll go back to the GitHub repository and then follow the command for running the tests. Pretty straightforward. OPA test policy.
Right. And that policy is just referring to that policy folder that we had.
All right. So as you can see, in the policy folder, we have the policy, the terraform.rego, the data.json, but now we just added the test_terraform.rego. So let me add that OPA test policy. And as you expected, pass 2 out of 2. Peter just explained why it passed, because we're saying that this test is for allowed dev deployment. The mock data is Google North America Northeast 1, which is the development environment, so it should pass. And the second one is not allow prod deployment. And because, again, the cloud name is the Google North America Northeast 1 region, so the prod shouldn't have allowed here. The prod is the AWS US East. And that's why, because it's a negative test, it's passed. Like if it was a positive test, then Peter, it'd fail, right?
Yes. And so, right, like here, it is, we have a little bit of a structured control here. So we know this is going to work exactly as we expect it to. So we did add some challenges in the GitHub repository. Maybe let's pop back over there, right? And so for those additional rules that we created earlier, right, now we want to add unit tests to those as well, right? And so as interesting as you made your rules, right? Maybe you included more built-in functions, right? So now we're going to run unit tests around those, and you want to make sure that those built-in functions that you added are behaving in the manner that you expected. So if you added new types of data, if you added a JWT token, if you added something else, you might want to test that specific functionality. Like with any unit testing framework, you can get as detailed as you want. And so, right, double-edged sword there with unit tests that I've definitely had experience with. But yes, and so we encourage people to write your own unit tests for the policies you've created and let us know how they went.
Yeah, and just like other lazy developers, Peter and I are lazy. We don't want to do all the work. So that's why we have 2 more test cases to write to help Rapu. It's for a good cause, but we would like you to write these tests for Rapu. But hey, we're not leaving you in the dark. Peter, there is help. Where can they find help in case they're stuck?
Right. And so inside the top level folder structure, we have the solutions in here. So if you do get stuck or you kind of need a guiding hand, right, we have these solutions in here that show a simplistic solution to the problems that might give you ideas to create more creative solutions to creating those policies and unit tests.
Yeah, but don't look at the solution first, right? So first we'd like you to try, and then you can look at the solution.
Yeah, don't start at the end.
Yes. So I'm going to stop sharing, and then let's do a quick wrap up on what we discussed. So of course, there's a ton of information, and we started with a challenge. The challenge is for any engineering team. It's not necessarily only Rapu, but any engineering team, when they have those keys to deploy to different clouds, that's like a superpower. And they can deploy to different cloud and create different resources. But with great power comes great responsibility. You need some guardrails in place. And in this demo, we showed how you can use Aiven platform to create cloud data resources in a simple way, and using Terraform as the tool of automation. But then we added open policy agent so that your deployment has some guardrails, and you can check which deployment are allowed and which deployment are not. Peter, why don't you talk about the next segments, which is like the best practices and unit testing?
Cool. Yeah, sounds good. And so with that, right, like, so we're now combining these tools. We have a couple of open source technologies, right? We have that very flexible Aiven data infrastructure tool, which is where open policy agent really shines, because now we can take all that information and shove it into OPA and make those really robust policies. And so now that we've defined that, right now we add on this unit testing, or this testing framework on top of it, right? And so that's going to give us the complete development a life cycle, right? But in this particular case, what we're developing is policy. So I like to say policy development life cycle, right? Kind of a little play on words there. And so, but that idea rings very true, because you have a certain way of working when you are writing code. And that same methodology can be used here when you're defining your policies, because you're going to do a little bit of research up front before you write your policies, but then you're going to want to check those policies before you ever roll them out. And you're going to want to do all of this in an automated fashion, such as wrapped around like a CI/CD pipeline or something, right? And so it truly is very one-to-one with a software development lifecycle. And so making sure you have each of those components and the correct testing in place every time you are pushing these policies into your production environments.
Thanks a lot, Peter. And again, the GitHub repository would be in the description box. Try it out. If you have any questions, you can comment on the YouTube video. You can reach out to Peter or I. Our Twitter handles are there. We'd love for you to try out this demo yourself and let us know if any feedback you have. Thanks so much, Peter, for joining today and helping Rapu in the first few weeks of his new job.
Cool. All right. Thank you, Dewan, and thank you to everyone who's watching. We will see you next time.